Hello, I'm Jainie. I'm a research assistant in Newcastle University. I'm working in an interdisciplinary research team named Sir Joseph Swan Center for Energy Research, in short, Swan Center. The center is led by Professor Tony Roskilly, who is also the chair of marine engineering. The center incorporates more than 300 researchers from 11 academic schools specializing in engineering, physical, and social science. The center provides the focus for all energy-related research. I'm working on Work Package 6, Environment, Safety, and Risk Analysis. For the internship, my work in particular is related to the economic and environmental assessment of marine power plants on board cargo ship. There are a few configurations under study, including the conventional plant, the retrofit designs, and new build designs. In doing my task for the internship, I collect data and information from research partners and other sources. Then I standardize the input data and use them to create LCA models. The software I'm using is Gabi. And based on the small LCA models that I created in Gabi, I ran different scenarios to investigate or identify the key performance indicators and the impact of individual parameters on the overall environmental burdens caused by each configuration. According to the Organization of International Standards, life cycle assessment is the compilation and evaluation of inputs, outputs, and the potential environmental issues caused by a product system. A product system can be a goods or a service. The life cycle of a product system consists of a few phases, from the engineering and design approval, acquisition of raw materials and energy, manufacturing of intermediate products, assembly, installation, operation and maintenance, and the end of life. Examples of environmental issues caused by a product system are climate change, ozone layer depletions, eutrophication, acidification, toxicity, etc. Life cycle assessment is important because it raises awareness of the environmental issues caused by a product system. Life cycle assessment estimates the potential environmental impacts of a product system throughout its life cycle. This is an example of LCA model created for internship project. The model was created from one of the main diesel engines employed on board the reference ship. The model covers component manufacturing, operation, maintenance, and end-of-life phases. To create the model, coefficients and parameters were derived and incorporated with inputs and output data. Upon completion, the model was run to estimate potential environmental burdens caused by the component. A number of scenarios were also run for sensitivity analysis. LCA models for other components and technologies were created in a similar manner. The LCA results will firstly stir the research directions towards advanced technologies and sustainable products, which are more environmentally friendly. The outcome will play a role in assisting industrial organizations and policymakers in their decision making, leading to the uptake of the such technologies and products for a low carbon future. The internship project covers 4 important elements, namely technical environmental, risk, and economic aspects. The outcomes from the Inoman-ship project would that they be able to convince the shipping industry to uptake those configurations for marine power plants under study. The results shows that the configuration, the state-of-the-art configuration, i.e., full electric configuration for new builds are the best solution. In addition, the results also show that retrofit designs is more viable than the conventional design, if not as good as the full electric configuration for new builds.